think that touching water feels insanely cold, even if the water and the air are at the same temperature. And it's not just water. If you touch an iron bar and a wooden bar in winter, the iron feels much colder. So how can two things at the same temperature feels different? This is due to the great misunderstanding with temperature. You see, we do not actually feel temperature. What we feel is heat leaving our body. The transfer of heat is what we feel as cold. Your skin is usually around 33 to 34 degrees Celsius. So whenever you touch something cooler than that, heat flows from your body into the object. The faster the heat leaves, the colder it feels. The same idea can explain why iron feels colder than wood bar. Since metal is a very good conductor of heat, when you touch iron, it steals heat away from your skin. Wood, on the other hand, is a poor conductor, so it removes heat slowly. Now when you come to water, water feels significantly colder than the air. It's because water conducts heat much better than air. In fact, water transfers heat 25 times better than air. So when you put your hand in water, your body heat escapes quickly. Your skin temperature drops faster, and that's why water feels so colder. In fact, when you touch air, the air near your skin warms and it stays there. The warm layer acts like an insulation, but water moves. As soon as the water touches your skin, it gets replaced by the cooler water, so the heat is continuously being pulled away. So temperature alone does not decide how cold something feels. What matters is how fast heat leaves your body. Before going away, I have a paradoxical question. Imagine placing an ice cube on an iron bar and one on the wooden bar, and when you touch them, the iron bar feels colder. Now the question is, which will melt ice faster? When you touch iron, the iron feels much colder, so you might expect the ice on the iron to melt slower because it feels colder, but the opposite happens. Because metal transfers heat better, the iron pulls the heat from the surrounding and delivers to the ice. So what we feel colder is not actually colder. It's just better at moving heat.